In this video, we are going to discuss about the Zigbee. So, by the end of the session, the students will be able to understand the low rate principles of low rate wireless personal area networks and able to analyze the architecture layers separating this physical and MAC standards. This will also used to evaluate the individual roles of the coordinators, routers, and end devices. So this is the outline we are going to see. Here is the first part of the structural outline for today's section. So we will cover the biological origin of the name Zigbee, which defining the technology's generic characteristics. Then we will be going for the core block and the functional protocol overload network topologies. So continuing with the outline, we can see the Zigbee relates to the underlying IEEE standards, where it evaluates a technical wireless comparison chart against competing protocols, and finally it concludes with the core biomedical and industrial applications. So where does this name Zigbee comes from? It is actually modeled after the domestic honeybee colony. A honeybee hive relies completely on continuous, highly organized communication among thousands of worker bees to locate these sources. When a bee discovers a new food resource, she returns to the hive and performs a silent but incredibly powerful communication. So that is zigzag pattern. So the same thing is used here, same purpose is used here also. So to define it formally, Zigbee is an ad hoc wireless mesh networking and standard designed specifically for low-rate wireless personal area networks. Also, it builds directly upon the IEEE standards, where it defines the underlying physical and medium access control layers. So this Zigbee provides a robust mesh networking surface and low in its cost and the power replace are very low. Like Wi-Fi or Bluetooth is expectedly very low cost and the minimal power consumption. So the technology is highly robust, offering the self-configuring and self-healing properties. It is actually designed to the network with the inexpensive battery powered sensors. It is achieving 250 kbs on the global level only. So the general characteristics, so it provides built-in support for low latency devices and also utilizes a carrier sense multiple sensors access with the collision avoidance, that we call it a CSMA channel for preventing this transmission collisions. So most importantly for the biomedical engineering, it operates on an extremely low cost cycle. From the research, this underlying IEEE standards of finalization May 2003, followed by the rectification. This opened the technology in the public availability also. Even modern researchers are heavily using this synchronization for sensor clusters. And the major market requirements is that is the primary requirement was global license free operation. That is, this system is requiring automatic or semi-automatic installation, which is allowing the sensors to dynamically add or remove without any break in the network. So this offers up to 10 to 75 meters in a typical home or in a clinical environment itself, or it supports a high density cooperative networks also. Easily it is achieving an operational battery life of nearly 2 years. So with these foundational characteristics, we will move to the next module also to analyze the internal characteristics, that is internal protocol stack and the hardware configurations. Thank you.